Alright, so chapter 16, dynamic range. This will go fairly quickly. Dynamic range is essentially just the difference between the smallest value and the largest value. It's always expressed as a ratio, so that you can have it be measured in decibels. If you do that, if you're using power, so the dynamic range in power is the smallest power available to the largest power available, you would multiply 10 times the log of that ratio and get a dynamic range in decibels. If you use anything other than power, if you utilize values such as volts or anything that would be measured with amplitude, if you recall that power is related to the amplitude squared, so then you have to square that ratio, and when you square a ratio and take the log of it, it's equivalent to multiplying it by 2. So in this case, the decibels becomes 20 times the log of the ratio of the amplitude difference. Okay, so either way, whether you're using power or amplitudes, you can come up with a decibel range. Now, when we talk about dynamic range in our system, we're talking about the relative sensitivity of the equipment to voltages, and so we're typically using the 20 times log ratio equation. But because we're looking at the dynamic range in the system and its sensitivity, we have to remember the most sensitive item that we have is the transducer, and then our sensitivity decreases from there on down. And so the receiver can handle up to about 120 decibels. The scan converters that the receiver gets, it sends its information to, only handles 40 to 50 decibels. So when you're adjusting the dynamic range on your system, you're changing the dynamic range in the receiver. Okay, and then everything else goes from there. So the dynamic range of the scan converters is usually 40 to 50 decibels. Our display is only going to have a dynamic range of 20 to 30 decibels. And then our storage will have a dynamic range also about 30 decibels. And the real limiting factor in imaging is, especially grayscale imaging, is the human eye, because we can only see approximately 25 decibels of grayscale in the human eye. So that's the actual limiting process, is what we're able to perceive. Compression is a technique which allows us to reduce the dynamic range. There are errors that are introduced when you compress something. It keeps the ordinal ranking, so the highest things are always the highest and the lowest are always the lowest. That's an ordinal rank, but it reduces the range of the values. So as an example, you could potentially earn points in a course ranging from 0 to 100, but then the faculty then compresses that down to a very narrow grade group between A to F. So even though, you know, you may have a 89.99, that would fall into the same category as an 80.001. So you can see that there's a wide range there that gets compressed down to, in some cases, a very arbitrary number. So everything between 80 to 89 is compressed to a B, and essentially is an 85, and everything below an F is from 0 to say 59 or 69 is considered a F, which is a very large range to be compressed into. But the idea is not to get you worried about grades here, but to talk about how compression can work, moving points into a different system. On our machines we have a button called dynamic range, and this, what it does is it provides the number of gray levels available to the image. And so if we have a dynamic range is 72, which is the normal setting for most of our images, we see a lot of different shades of gray at that level. If we turn that up to or down to 42, we don't see as many shades of gray, but we get a sharper image. We get a more contrasty image. So here is a couple of shots of a liver, and you can see that the one on the left has more gray to it, whereas the one on the right is certainly has a sharper contrast, what we would call less dynamic range. Thank you.